PreAP PreCalculus Notes 4.1. We just did the fundamental theorem of algebra in the first video, and now we're going to look at Descartes' Rule of Signs to help us determine how many of the roots can be positive and how many of them can be negative. René Descartes was a mathematician of his time to whom much of the modern mathematics is accredited. If you ever heard of a Cartesian coordinate plane, Cartesian comes from Descartes. One such concept that carries his name is Descartes' Rule of Signs. The maximum number of positive, let's just do positive first. The maximum number of positive roots of a polynomial function is equal to the number of sign changes of f of x, or is less than that by an even amount. As far as negative, the maximum number of negative roots of a polynomial function is equal to the number of sign changes of f of negative x, or is less than that by an even amount. Let's check this out and see if we can make sense of this. If f of x, the original function, has 7 sign changes, then the number of positive roots, it's positive because this is f of x, would be 7, or is less than that by an even amount. But what's 2 less than 7? 5. What's 2 less than 5? 3. What's 2 less than 3? 1. You stop when you get to 1 or 0. If f of negative x had 6 sign changes, then the number of negative roots would be, there are 6 sign changes, or less than that by an even number. So you keep subtracting 2 until you get down to 1 or 0. If you're plugging a negative x into it, it's giving the negative roots. If you're leaving x alone and it's the original function, it's the number of positive real roots. 7 sign changes, 7, 5, 3, or 1 positive roots. If there are 6 sign changes, when you're putting a negative in, there are 6, 4, 2, or 0 negative roots. If there are 2 sign changes for f of x, the number of positive roots would be 2 or 0. If f of negative x has 1 sign change, then the number of negative roots would be 1. Let's consider this function, p of x, and then we're first asked to find, well, what's the equation of p of negative x? P of negative x, this is real simple. If you're putting it in here, and the exponent is positive, which it is here, there's no sign change. So it stays what it is, 2x to the 4th. If you put a negative x in and the exponent is odd, let me start over because I think I misspoke. If you put negative x in for x and the exponent is even, I think I said positive before. If it's even, then this stays the same sign. It's 2x to the 4th. If you're putting it in and the exponent is odd, it's going to change the sign. So it's a negative x cubed. Even, so it stays the same. Odd, so it changes sign. No x to put in, so it stays the same. For us to find the equation of p of negative x, go ahead and write that little fella right down here. Descartes' rule of signs is dependent upon the number of times the signs of the terms in the polynomial equation change signs. In the boxes below, write both the equation of p of x and the equation of p of negative x, then count the number of sign changes. So we already got this fella. So how many sign changes are there here? No sign change. There's a sign change. There's a sign change. There's no sign changes. There are 2 sign changes. The number of sign changes in p of x determines the maximum number of positive real roots that the function can have. So the maximum number is 2, because there are 2 sign changes. And this is for positive real roots. If we take p of negative x, sign change, no sign change, no sign change. This was supposed to be a 3, a plus 3. Somehow I didn't write the plus. I apologize. 2 sign changes. The maximum number of negative real roots for this is 2. So it could be 2 or it could be 0, just like for the positive ones, it could be 2 or it could be 0. A function can have the maximum number of positive or negative roots of any multiple of 2 less than this maximum. For example, if a function has a maximum number of 4 positive roots, it could possibly have 2 or 4 positive roots. If the function has a maximum number of 3 positive roots, then it could have 3 or 1 positive roots. If a function has a maximum of 2 positive roots, then it could also have 0 positive roots. So looking at this equation here, and this is summing up what we just did. This is this entire column. It's the same function. How many positive roots are possible? Well, we said there were 2 sign changes, or is less than that by an even amount. For the same function, how many negative roots are possible? That was using this fellow right here. There were 2 sign changes, so there could be 2 negative real roots or less than that by a 0 amount. So this video was focusing on how we can determine the number of positive and negative real roots that exist. And Descartes' Rule of Signs tells us how to do that. The next video that I'm going to make is determine how many of the roots can be 0.